The way you create custom objects in Python is through the use of classes. And the way you create a class is with a class keyword and the name of the class. Note that this class name is usually camel case in Python. That's simply a convention, but your class names should look like this, as opposed to a variable name, which is lowercase with underscores, same as methods or functions. But your class name's camel case. So, class person. Normally the first method in your class is the constructor, and the first argument is self. Now technically, this does not need to be the word self. It could be this. You could call this variable whatever you want it to, but people are going to look at you funny if you don't use self, because that's the convention in Python. This self is a reference to the instantiation of this object. So when I create a person object, this self refers to that specific instantiation. I can use that to create things called instance variables. These variables exist per instantiation. So my copy of person has a name and an age, and your copy of person has a name and age. Notice I have underscores in front of these variables here. These make these private variables, although this is merely a convention. Those variables are still accessible. In Python, there's no such thing as public and private, not really. Notice I can still reference those variables. You may see something like double underscore in Python. And what that does is that does something called name mangling. Notice I can not access that directly. And so you may think this is a good way to create private variables, but technically that variable is still accessible. The name is just mangled. And you can still modify it directly. The PEP says this really exists if you want to prevent conflicts between parent and child classes. So conventionally speaking, if you want to denote a variable as private, you use a single underscore. Same thing for methods you want to deem private. You can also create these as read-only attributes. By using the property decorator. Again, I can't prevent other programmers from accessing these instance variables directly, but I can write this and provide you an interface such that I'm telling you this is how you should be using this. Notice I cannot modify these directly. But Python does allow for both getters and setters for these kind of properties. You use the name of the method .setter and provide a value to set it to. This affords you the ability to do things like put constraints on what could be assigned to these values. All right, let's see if this works. The way Python handles inheritance is pretty straightforward. So you want to have a kind of person here called a student. You simply put the parent class in parentheses here. This causes your object to inherit everything that the parent has. I'm going to have a call to the parent constructor using super. What this does in effect is it says do everything that the parent constructor does, but then I can do additional things too, like create a list of grades. Notice that I'm not recreating the name or age properties because I will inherit them. This is a method, and because I have no leading underscore, it's considered a public method. Python also has things called static methods, and we mentioned private methods too. So let's say I want to provide a property for grade. And I can return the student's grade. Well, I'll reference some private method. Again, it's not really private. You could still access this method directly. This is just a convention. Now, notice there's no self-reference in this method. That's because I'm not actually referencing any of the instance variables. In this case, you have to use the static method decorator. This tells Python this isn't referencing any instance variables. Again, I wouldn't write a real class like this. I'm just using this to demonstrate properties, public methods, private methods, and static methods. And those are the basics of Python classes.